Good day, folks. In this video, I'll be talking about the change in momentum with respect to the force. Change in momentum with respect to force. Now, basically, we are trying to learn the definition of the momentum, how the force will affect it. So, in the last class, we talked about that change in momentum can be called as area under force times graph. Force time graph or FT graph. Now, if it is like a triangle, then the answer will be force peak. This is peak force peak multiplied by change in time, which is equal to change in momentum. Now, if the graph looks like this, a horizontal line, I'll call it as an average force average, which is because it is not changing over a period of time. That's why I'm calling it as an average force. And this is the time, delta t. So the formula will become F average times delta t. You can call it as an average, net average means one and the same thing. So delta p. Now, I'll take an example and try to find out how does the force affects the momentum. Now imagine you have an egg in your hand and you drop it onto the bed. Okay. And if you drop it onto the bed of in your home, what's going to happen? The chances are the egg's not going to break. But same egg, if you drop it on a hardwood floor, the chances are that egg's going to get shattered into pieces. Why does that happen? We can understand this concept, why the egg shatters, with the help of momentum, or shall I say change in momentum and the force applied. Now, let's imagine the mass of an egg is 10 grams. Just for the sake of this question, I'm going to call it as 10 grams. And then uh, if it moves with the velocity of 10 meters per second just before it strikes the ground or this bed, the velocity is 10 meters per second down here. So what is the momentum in that case? Initial momentum, I'll call it as, that will be mass times velocity. So 10 grams mass, again, if you can recall the last lecture, we said that units of momentum is kg meters per second. So I need to convert this grams into kgs. So this will be 0.010 because 1 kg equal to 1000 grams and multiplied by velocity. And velocity is, in this case, it is 10 meters per second moving in the downward direction. Now, because it is moving in the downward direction, so I can use the negative sign. This is down. So this is negative. So this will be equal to, if I multiply both of them, 0.10 negative initial momentum. And once it's going to strike the bed, it's going to come to the rest. So the final momentum in that scenario, I'll call it as 0. So what is the change in momentum in that case? P delta P is equal to P final minus P initial. Notice that's going to remain the same in both the cases, whether you're throwing it on the bed and whether you're throwing it on the floor. So assuming you are throwing it from the same height and this egg covers the same amount of distance. So down here, the velocity is 10 meters per second just before it strikes the ground. Now change in momentum will be equal to negative 0.10. Oops, the final is 0. So 0 minus 0.10. So P delta P comes out to be 0.10 kg meters per second. And this because the conditions are same, so in both the cases, in the other case, this is the second case, and in the both cases, the change in momentum will be 0.10 kg meters per second. So if the change in momentum is same, but why the egg breaks down in this case and egg doesn't break down in the very first case? So let's take the very first case. So change in momentum is equal to force times delta t. Let's say if I talk about the average force felt, average force multiplied by delta t. Now I wanted to find out how much the force is being felt by the egg. That's what I wanted to find out in the very first case. So time spent, let's say in the very first case, when the egg's gonna hit the bed, it will take almost, I would say, 1 second to stop down. Okay, because this bed is really a soft bed, and you once you're going to throw it, and when it is about to strike the ground, it will strike it, but then because of this bed is so soft, this egg will come to the rest over a period of time. Let's say that period of time is 1 second, and now you multiply this time period here with 1, and force average, and delta P is 0.10 kgs. So how much force is being felt by the egg? That will be, I divide both sides by 1, and that will be 0.10 newtons. The units of force is always Newton. Okay, and that is the force felt by the egg in the very first case. Now in the second case, same egg, once you throw it on the ground, this egg, you drops it onto the ground, it comes to rest within a split second because this is a hardwood floor. It's not going to get compressed. So let's say it comes to the rest within zero point 0.1 second. So I'll write down the formula again. Force average times delta T, which is equal to delta P. And now force is what I'm trying to find out. How much average force is being felt by the egg, multiplied by zero point 0.1. And this is zero point 0.1 down here too. So if I divide both sides by zero point 0.1, 0.1 cancels out. This comes out to be 1 Newton. So did you see the difference? In the very first case, the force felt was, average force felt was 0.1 Newton. This was the impact on the egg. In the second case, the impact felt by the egg was of 1 Newton. So thus, in which case the chances are more, because in this case you will see that the force felt is more, so the chances of breaking the egg will be more in the case when it's gonna strike the ground. Now, where we use this in the real life. So in case of cars, when you drive a car, and let's say this is a wall. If this car hits this wall, if this car comes to the rest within a split second, this car comes to the rest within a split second, then you will find out that the force felt will be more by the driver. Whereas if this car crashes into this wall and this front portion of the car breaks down, starts collapsing, and the car slowly comes to the rest over a period of 1 or 2 seconds, let's say 2 seconds, then force felt by the driver will be less. So that is the practical application of the change in momentum and the force felt. So hopefully you were able to understand what force and what is the relation between force and the change in momentum is. Now I'll talk about the units. So change in momentum is equal to, as I said earlier, kg meters per second. These are the units we studied. Another formula which we wrote was change in momentum is equal to force average times time. So for the timing, I'm going to use this formula. Now, what are the units of force? Units of force is Newton times time, and this is equal to delta P. Now, time unit is not time, times unit is seconds. So earlier we wrote down this as a unit. Now we are saying Newton times second, which is Newton second. So we will try and see how they are one and the same thing. So change in momentum equal to kg meters per second. If I break it down, Newton is what? Mass times acceleration, which is kg meters per second square. So if I'll break it down as kg meters per second square times seconds. So one of the seconds will cancel with the seconds, and then I'll be left with kg meters per second. Kg meters per second equal to kg meters per second. So thus you can write down the units of momentum as kg meters per second or Newton second too. Both are one and the same thing. And change in momentum is also called as impulse. Impulse. Okay, and represented with symbol I. So if you are asked a question on impulse, don't confuse yourself. It means one and the same thing, which is change in momentum. So hopefully you found this video helpful. And if you think of subscribing, that'll be great. And I'll see you guys with another video. Bye now.